Welcome, ladies and gentlemen. I got something very special in store today. I wasn't quite sure what I wanted to go with for our next project, but I figured it out. I've settled on a text adventure game. Now, here's the idea. I want to create one of these games and have some special elements. But first, let me show you what an existing one looks like. This is provided by Written Realms, as you can see. We'll just play a little bit of this game so we can kind of get an idea. Get used to the genre, so to speak. Alright, so you see here, it's all based on text, right? And this is one of the cool things about text adventure games and why I think they might... this is why I think text adventure games have become cool again, is because AI is great at doing normal English stuff with text, normal English, or, normal speech. Like, it can sound kind of like a human. It can pass for a human. So, this is a really great use case. I think we could have some fun features and some dynamic features if we use AI carefully. So here's the idea. Let's just go through. You're caught upside down in a sticky web of silk 3 feet off the ground. After looking around trying to think of a way out of this predicament, you notice that your trusty boot knife has fallen to the ground. If you stretch your arm far enough, you might be able to pick it up and free yourself. Click anywhere to begin. This is interesting. I think I tried this game before, and I had a different starting scenario. Okay. Now, you see it says, enter get knife, right? It wants me to type that in. Here's a place where I think AI could be really useful. What if I type a synonym for get? What if I forget the get command, and I want to do something else? Maybe I say take knife. Oh, it doesn't know what take means, right? But if I asked AI, hey, what do you think the user meant? Do you think maybe they meant get knife? Like, oh yeah, that's what they meant, So, here we go. You get an old boot knife. You wield an old boot knife. Oh, okay, and it automatically uses it. Okay, that's interesting. You use the knife to slice at the silk. As the web weakens, your weight tears through the rest of the fabric and you fall to the ground with a loud thump. Wincing in pain, you try to familiarize yourself with your surroundings. So let's look around. You don't see around anywhere. Okay, let's try look by itself. You have to leave by going south. Enter south in the command bar. Okay. Uh-oh. Webbed bones and dried membranes litter the floor of the cave, narrowing to the east, where the passage becomes cramped. A spider blocks the way. This might be a different game than the one I had before. And you'll notice I've got my health here. My health bar is at 63. My stamina is 100. What are these? There are no items in the room. That's cool. I have there are 2 characters in the room. Okay, there's me and a spider, right? Somewhere it might give my... I think this is a different game than what I was playing before. Anyway, you can see you have some little... there's some GUI elements here. Oh, it's got a map and everything. That's cool. A map is nice. Actually, that's kind of like... feels like cheating in the text adventure game because you can't quite tell what it looks like from the text alone. But you should have stuff like a score as well. This is maybe a different game. So let's kill a spider. Okay, we're stabbing the spider. Okay. Oh, you can flee, you can loot. Okay, I guess you can do stuff. This is different. This is a little bit advanced, right? Let's say loot. Oh, detached mandible. Okay, this is cool. Right, and then we're going to go west. I guess west is available. Oh, can't go that way. Let's look around. Corpse. Nearing to the east, where the passage becomes cramped. So let's try going east. Okay, we can go east. Oh, I hit west instead of east. Okay. Kill spider. Oh, okay. Got it. Okay. I'm not liking this one as much. It's got more combat than I'd like. I guess we're already... Okay, we already got it. Okay. Northeast. Northeast. Oh, great. Dead end, it says. Oh, but there's an exit south. Oh, north and east are separate exits. North. South. East. Health is really low. I'm probably going to die here, but anyway, you kind of get the idea. This honestly doesn't feel like the best example to me. let me just show you another game, right? Let me show you the game that kind of inspired me and made this feel like a fun project to do. I got it here. Let's see, Zork. There we go. Do I already have a Zork? I probably don't. Okay, there we go. Okay, so we have. I have like 4 different versions of Zork here. We're gonna go with this one. Oops. Oh, there we go. Okay, here we go. Now this one is a command line only game, and I built it from source, so whatever that means. Anyway, you can see this one. It says "Welcome to Dungeon." Basically, this game got renamed to Zork at some point, and you can see this game was created in '91. That's incredible. I was very young at that point. You're in an open field west of a big white house with a boarded front door. There's a small mailbox here, so you can do different things like maybe we want to look at mailbox. Nothing special about it. Let's try opening the mailbox. Ooh, there's a leaflet in there. Let's read the leaflet. Now you'll notice I said read leaflet, and it says taken. So it interpreted read as take, and then read, I guess. So this gives a little description of the program and kind of gives you like, hey, check out help and info commands, right? The original version was written in Muddle, which, from what I can gather, is some sort of sub language. It's like a DSL language that was written in Lisp. This game came from MIT, and I'm guessing it probably had I'm guessing the authors probably had some sort of relationship with the AI researchers there. It does have pretty impressive understanding of English for the time period, I think. Anyway, but that's something we can help with now. We can use an LLM to try to parse what the user says. And if we use a local LLM with a small model, it should be pretty quick. So that's probably what we're going to do. Let's try the info command. Okay, got it. Oh, I didn't read this last time. Okay, cool. Oh, to receive credit. Oh, this is interesting. To receive credit for the treasure, you must deposit it safely in the trophy case in the living room. Oh, so much is making sense now. Okay. A special note is a thief, always carrying a large bag, who likes to wander around in the dungeon. He's never been seen by the light of day. He likes to take things, since he steals for pleasure rather than profit and is somewhat sadistic. He only takes things which you have seen. Oh. Oh, this makes so much sense. Interesting. So, I went to this room in this dungeon when I was playing before. I went to this room and there was this really expensive looking thing there, and I thought, I'll leave that for later. I didn't do anything with it, and it disappeared after a while. I'm like, is this the same room or is it a different room? Were there 2 rooms or one of them is empty, or did this just disappear? So much. This is so exciting. Okay. I learned so much right there. But anyway, if you read the help, you can see like there are only a few commands it understands. And if it understands a few synonyms, but it doesn't understand everything. It tries to be clever. If I've got a parser and it's clever enough to figure out what's going on and resolve the ambiguity down to one thing, then great. But if it fails, I can always turn to AI and ask it to give me a second opinion. Like, hey, can you resolve the ambiguity, Right. So, so that's one thing I can do. Now with this game, you type in score to see your score, and you type in I or inventory to see your inventory, right? And you can say, like, for example, I could say drop leaflet. What if I say lose leaflet? Yeah, it doesn't know what I mean, right? Of course, maybe that's a little bit ambiguous. So we drop the leaflet. We could take it again. What if I say get leaflet? Okay, it does understand that. Drop. Oh, it figured out what I meant. Because I only had one item. It knew what to drop. See, it's kind of clever. What if I said something like... Well, anyway, we can go into this in more detail later. But this is kind of a cool game. let me just kind of show you how to get in there. So let's go. Let's look at the room again. There we go. We're in an open field west of a big white house. We go south. Now we're at the south side of the house, and we'll go east. Now we're behind the house. Oh, looky there. There's a window that's slightly ajar. Wonder what we do with that. Open window. Okay, it works. Enter. Great. Now we're in the kitchen, right? Oh, there's a glass bottle. What else? Okay. There's a table that's been used recently for the preparation of food. That's interesting. So someone else is in this home. A passage leads to the west. To the east is a small window which is open. A dark staircase can be seen leading upward. Interesting. So let's open the sack. And there's a lunch inside. Take lunch. All right. Let's go up the stairs. It's pitch dark. You're likely to be eaten by a grue. So you can see when we're in the dark, we can't do anything. We got to figure out some way to dispel the light, or the darkness rather. Let's go back down. And then let's try going west. Well, here we're in the living room. And, you know, I could read all this, but I just want to point out that right here is the trophy case. And I just now figured out what the trophy case is for. So let's try, what do we have in our inventory? Put lunch, let's look at our score first of all. Score. Now we did get a score. Okay. Basically what the score means in this game is it just means we did some of the right moves. We made some good moves. I think you get 10 points for entering the house, basically. And then let's try this. Put lunch in trophy case. I can't reach this. Open trophy case. Put lunch in case. And you can see I abbreviated trophy case and it still figured it out. And then let's look at the room again. Close trophy case. Now let's look at our score and see if it's gone up. It hasn't. Okay. Anyway, this kind of gives you an idea how you play the game. One thing about the living room, there's a door. To the west, there's a wooden door with strange Gothic lettering. It appears to be nailed shut. Let's say read door. The engraving translates to this space intentionally left blank. I love the little jokes here. Like, you'd think, you know, it's Gothic lettering. Maybe you have difficulty reading it. I guess it's the same language, just different lettering. Anyway, yeah, maybe you'd think you'd have difficulty lettering, but it's like this space intentionally left blank. So they give you those little jokes. They translate things that maybe they shouldn't, just to make it funny. But that's pretty cool. Anyway, I want to make a game like this, and I thought, what would really make it special? What's something we could do in this day and time that would make it special? Oh, see, when I say exit, it thinks, I don't know what it thinks. I think it means I want to go outside. I want to quit. Do I want to leave the game? Yes. Okay. So I had some ideas for what to do. Actually, let's go ahead and start a new. Let's start a new adventure game. Okay, unfortunately, I have to close some other things in order to be able to move this. Okay, so here's my idea. Dead simple. This is our goal 1. We want a dead simple game that works. Dead simple MVP. Right? And then later, the cool things we can do after we get an MVP is we can add AI storytelling. AI ambiguity resolution. Or AI, let's say AI parsing. Resolve ambiguity. Or, and I guess since AI isn't perfect, what I might do is I might ask AI, hey, please resolve this. Tell me what the user wants to do. Here are the available actions they can take. Here are the objects that they're able to interact with. Here are the entrances and exits they're able to interact with. Tell me what they mean in this context. What do they mean? And it might come back with an answer, and I could say, I could say to the user, hey, is this what you meant? Yes or no? And if they say yes, then I just do what the AI suggested, right? So that's a way I could let AI provide something useful and make it feel more alive, because it makes it feel like, one of those shortcomings of playing the game like Zork is you give a command and it doesn't work. Like, actually, in fact, this was a big problem for me when I first started playing this genre. Was I'd start out in a place like this and I expect to be able to do something and I can't. Like, for example, knock on door. Oh, okay. They actually checked this one. Okay, I don't think anybody's home. That's they do check that. But like, for example, what if you want to lay down? Yeah, it has no idea what you mean. Dig a hole. It doesn't know. Look at grass. Yeah, it has no idea what I mean, right? So for AI, right, you could use AI and say, hey, the user is trying to perform an action. Here's another thing. The user is trying to perform an invalid action. Invent some snark. Make fun of them. Give snarky comebacks when the user asks to do something impossible or stupid. Or weird. Let's just say weird. Another thing it could be used for is to do storytelling. Could add some flair to rooms, to room descriptions. If we're careful to keep it vague, it should avoid distracting the user. It should add realism, immersion, let's say, without distracting the user too much. One problem is if the room descriptions change, you might think there's something significant to the puzzle. You might think there's some reason why you need to pay attention to that, when in fact it would just be the AI making something cool just to immerse you a little more. So we got to make sure to balance those descriptions a little bit. We may be able to get something good out of the AI that still is good play. And if we can't, maybe we just add a mark there to say, yeah, this is generated by AI. Don't pay too much attention to it. Just enjoy it. So that's the idea. Give me a sec. There we go. Okay, so that's the idea. Right. Our other idea, though, and this is so cool. I think it's even better than the AI thing. I would like to make it multiplayer. Granted, this is much harder than the AI thing, too. So maybe we do this first. Yeah, this would be pretty fun just to do the AI stuff. It's really low-hanging fruit. Once we have a working system, it's low-hanging fruit to do this. Now, the first thing we want to do is have a very simple storyline. Well, actually, there are steps to this. I'm not going to list it out here. But yeah, let's do this here. Dead simple MVP. 1. Define world and types. You'll see what I mean by that. This is how I always start a new project, is with the types that I'll need. It kind of helps me understand the data better. But we'll get to that. The next thing I want to do is, well, create an import-export process, first of all. Get import-export working from YAML or JSON. Probably use JSON. Let's just say JSON. Right. And then we're going to, because that should be a relatively short step. When we define our world, we need to make sure we stick to things that are easy to serialize. We don't want to add like a bunch of, whatever. We'll get there. We want to add simple types, not complicated stuff that has a lot of state or hidden state or thread local stuff, right? We don't want transient data and whatnot, all of that stuff. Anyway, that's something we'll have to pay attention to when we're defining our world. But then our import process should be relatively simple. The next thing we're going to do after we get that is we're going to create a simple storyline. A simple story with several rooms and objects to test out the functionality. Several rooms, objects, and actions to test out the functionality. We want to get all those things in, right? So this will be basically our test case. Let's just call it a functional test. That's what it is. 4. Implement all the functionality of the simple story. Okay. And then at that point, we should then be able to think about making a more advanced story. And probably to support a more advanced story, we'll have to add a few things, I bet. We'll have to figure out how to deal with, well, you know, there are fun things we can do with specific... What we're essentially doing, one way to look at this is we're creating a programming environment, right? When you look at this, right, when you play Zork, what is this? It's kind of like Python or Bash or any other command line language. It's kind of like, it's an interpreted language, right? Like you're giving commands to the system which affect the system, right? Like, for example, open mailbox, right? Well, I can type a command in Bash that will open my email. There's not much of a difference, right? So one way to look at it is we're creating a programming environment, a programming language. So a lot of the same concepts that you would have if you're making a toy compiler, for example, or a toy interpreter, are going to apply. For example, we're going to have runtime state, right? One part of the runtime state is the character inventory. You know, also the state of the dungeon. You could call it a dungeon, or you could say the game or the world. The state of the world is a good one, because maybe you don't want a dungeon. Maybe you want to call it something else, you know. Maybe you want to support other types of content. I don't know. Anyway, you have the state of the world, right? That'll be some runtime state. And you kind of have the question, and I kind of have an answer in my head already as I'm thinking this through. Let's just go ahead and ask the question. How do we represent, how do we handle changes that happen when the main character is absent? Or I should say where the main character is absent. Because the main character is always somewhere, right? Like, for example, in the game of Zork, as we just learned, if you go into a room and you observe things, and then you leave the room without taking them, well, the thief might come in behind you and take them. And so now they're gone, right? There's some chance that the thief will take those things that you missed. So, yeah, that's a reality. So that's, yeah. And it's fascinating because I spent a lot of time exploring the Zork game and I never realized what the objective was. I thought the objective was just to get your score as high as possible. But in fact, if you read info, the purpose of it is to get a bunch of treasure. So I have to play this again sometime and just see how fun that is. Let's quit for now. I don't like how it asks me multiple times to quit. It actually quits faster if you just hit Control-D. You just end your game immediately there. Of course, if you hit Control-C. So it's interesting. They support a good terminal interface, terminal UI, but at the same time, their quit functionality does something funky. And of course, seeing your score is good, but etc., etc. Okay. Anyway, so how do we represent changes that happen where the main character is absent? And basically what we're going to do is we're defining a monad over the world, or a set of operations over the world, more or less. Define a monad. The player character, let's just call this a player character, PC. The PC is one actor among many that can navigate the world and perform state changes. The PC's actions are controlled directly by user input. The other actors are controlled in an arbitrary way, yet to be defined. Probably what we'll do is have just a sequence of commands that they're planning to execute with maybe some way of doing conditionals, and then we'll execute X number of actions per minute, or X number of actions per second is probably aggressive. Probably X number of actions per minute while the player character is playing. Like we might want to have a thief or something. So, but that's kind of advanced stuff that we won't need for the MVP. So let's get rid of this. Well, no, we want to answer this discussion, but I do want to say, among many, not MVP, the other actors, not MVP. I want to just communicate that that's not what we're doing in the MVP, but I want to prepare for that in the MVP. I want to make sure we haven't, I don't even want to add the types in necessarily, but I want to make sure the way we use our types allows us to do that, because effectively what we need here is global state, right? We need a global world object which we can interact with, which can be mutated by the player, and navigate the world and mutate it. There we go. Yep, there we go. So every player needs to be able to interact with the world and mutate it. But it needs to be global in the sense of shared between all of them. And again, when I say global here, I don't mean it needs to be a global inside of my program. It needs to be global inside of the world. Like, in other words, from the player's perspective, it needs to be global. But that doesn't mean I need to store it in a global. Because it's kind of like when you're building your own compiler, you know. For whatever reason, languages tend to support having global variables. They're useful in specific cases. You know, you don't want to get out of control, obviously. But if you have, let's say in Python, right? Or let's even just say Rust. In Rust, they allow you to have global constants, right? Well, you can have a global constant in Rust, and it's constant in your program. It's not a constant in the Rust compiler, though. The Rust compiler doesn't even have that variable available to it other than as part of a unit of your program. So your program as a whole, your app, as it's being compiled or as it's being run, you can think of Rust as being able to interact with your program and mutate it and modify it however it sees fit to get it into a form that's where it does a thing, where your app works. Or you can think of the Rust runtime as doing something similar, whether it's the compiler or the runtime. And then, you know, one aspect of your program is it has access to this global constant in one of its modules, right? It's not an aspect of the compiler, though. It's an aspect of your program. So in this case, the world is going to be a global available to every program or every game, every playthrough. Yeah. And so it's going to be a global within the user's context, the user's idea of global, not within the program itself, not within the code for my game. So that's the idea. And I think to make comparison easy, I'm going to put my game right here with Zork, right? I don't know what to call it. So let's come up with some kind of AI name. And maybe we'll call it, let's see. I like asking AI for help for this when I don't feel like being creative. Synonyms for snarky name. Oops. Snarky name for a text adventure. Simulator. Textual tension. It's giving fortunately, it's giving names for maybe a, well, sort of. These are not quite. It kind of they're abstract enough it's hard to tell. Let's try it this way. A text adventure compiler. No. No. That's just dumb. Yeah, okay. Well, I guess I'll have to think of my name. Or I'll have to think of my own name, I guess. It's not... yeah, I could get it to be helpful with that, but it would take a lot more work. Gee, I don't know. I'm struggling with this. Another thing we could do down the road is add a GUI and add Bevy and stuff. It would be relatively easy. That could open it up to a wider audience potentially. So that's good. That's a good option down the road. All right, we're not going to think too hard about it. Let's make a directory called... Man, okay, so... I'm bad at this. I just got to... yeah. I'm putting all this pressure on myself to come up with something. Okay, so... my problem is I don't want it to be too generic. I want it to be kind of fun. Choice. I like choice. Costly choice. However, if I now I like costly choice as a concept of like you as an author of interactive fiction are able to provide meaningful choices to your consumers, your readers or your users, who then have to make critical decisions that are important. But if I call my app Costly Choice, it'll make it sound like it's a bad decision to download it and use it. But I do like the idea of choice. Synonyms for costly. It's going the wrong way. Synonyms for sacrifice. Oblation. Oblation. Okay. Wait. Synonyms for costly in the sense of making a sacrifice. Yeah, that doesn't make any sense. Costly, figuratively. Oh yeah, that doesn't make any sense. Okay, well, could call it personal. Intimate choice. I mean, no. I don't want to make it sound like a porn game. Particular. Singular. Distinctive. Okay. Close. Okay. Synonyms for adventure. Excursion, journey. Synonyms for choice. Let's do it these way. Synonyms for the phrase costly adventure. Wait. Which use alliteration. It's probably going to struggle with that. Pricey pursuit, dearest discovery, steep safari, lavish journey. That doesn't work. I mean, pricey pursuit sounds the best. Campaign. Costly campaign. No. Let's go with Pricey Pursuit. I should have come up with the name beforehand. One more time. I don't like Pricey so much, but I like the P thing. Premium? Okay, we're going to leave it. We're going to leave it. I mean, yeah. I mean, I think the original compiler for this stuff was called Infocom, so I don't feel like my I don't feel like my name choice is miles worse than that. Oh, and I've got this here document to try to plan things out, but yeah, I guess I'm not very good at using that. I usually plan things out with text. I was going to try something new, but we'll stick to what I'm good at, I guess. Cargo. Let's do this. Back out. Okay, great. Uh-oh. Okay, we're having trouble here with this. I know how to fix it, but it's just really frustrating. Okay, so... Right, the first thing we want to do is copy over the shell dot... shell.nix? Yes, let's copy that over. Shell.nix. And let's go ahead and do some stuff to fix... let's fix up... a language server. This should help. This should help with the error we're getting there. It'll help Nix as well. So let's try. Oh, I just realized cargo version. Oh, it didn't work. I don't know what our issue there is. Undefined variable. Oh. Oh shoot, I figured that out earlier. Oh, server. I hope I don't have to spend a lot of time debugging the editor right now, but let's move forward. Good. Now let's try, what's the cargo version now? Oh. Yeah, see, it's slightly different, so I gotta be careful with that. Anyway. I probably should uninstall Cargo by default so I can just do it in here, but whatever. So now if I open that, does it still give me an error? It does. Oh, it does. Okay. I mean, it gives me a different error if I'm using it, right? So let me just see if I can fix it real quick, because I know what I did. I can undo that and see if that fixes it. If it doesn't, then there's nothing I can do. Then we'll just make a choice of which error message is better. Here it was. Oh, here we go. Packages. Yeah, packages. Lua language server dot back. I think I realized the mistake I made now. Okay, Rust Analyzer isn't here. That's something I'll have to fix. I'm thinking I understand the problem here. Bin ls tech lh. Well, let's see where they all point. Okay. It points to... Yeah, that's a problem. Okay. Which Lua language server? Yeah, let's point it to there. Which Rust Analyzer? Okay, so that's a problem. I always get this backwards, so yeah, I did that backwards. That's why I don't do the force command until I get it right. Okay, failed to create. File exists. No problem. We overwrite. Okay. Right. Now the others I'm not going to mess with, but I do want Lua language server to be somewhere else. Let's do the same thing with it, though. Whoa, hello. My keyboard isn't very happy with me. Apparently I have to type that out. Great. Okay. Just a second. Whoa. Just a second. All right. Okay. So at this point, I think we're gonna have. I think we have them working. I think I just figured out what was wrong with that. I did promise not to. Let's see. CD. What did I call it? Pricey. I misspelled it actually. Let's move the shell.nix out, and then let's rename the thing. Let's make sure we can spell. Oh, it doesn't matter how you spell it. It's an alternative spelling. I like it better, but not that much better. Okay. Cargo init. Oh, actually, let's. Yeah. Cargo version. I don't think I'm going to upgrade today. We're not going to mess with any of that. We got a working version. So, cargo init pricey pursuit. Okay. Great. Here's this. Now, I like to have my source divided up, but I'm not going to do that for now. Just because. Just for purposes of time. So here's what we're going to do is we're just going to start working on a new file. Let's start with this. Okay, lots of issues. Well, I need to fix this. I think the alternative, though, is to use Cursor. Unfortunately, I was hoping... The problem with Cursor, though, is, yeah, we're not... I need to fix my Rust environment, basically, is what I'm learning. Cursor... Actually, ... Let's try that, see if that works. We'll see, okay. Actually, that's not going to work. Yeah. Hang on a second. I don't want to have that polluting my main window, so I need to do it differently. That's not what I wanted from life. Let's try again. Hopefully Cursor takes command line arguments. I don't even know. It doesn't. Okay. It ignores it. That's a real shame. There are lots of ways... Oh, gosh. Close window closes the whole application. There are lots of ways that Visual Studio, and by proxy Cursor, really misses the mark. I'm not disappointed that it's popular necessarily. I just wish that it were more accommodating. Because how do I close a project and open a new one? It's not clear. Close window? Well, that's kind of what I wanted, but I didn't want to exit the application. Why have close window and exit if they both do the same thing? You know? I mean, I get it. If I spend a week working with Visual Studio, I'll remember the differences, but coming back to it's always frustrating. You know? Okay, so here we go. Proj... I forgot. Oh, app. I almost forgot where I put it. Zork. And then we have this one, which we're going to open. There we go. Okay. Now then. Okay, it looks like it's working. And interestingly, yeah, okay. Now the only problem, man, so many issues come up. Anyway, whatever. We're not going to mess with that. We're just going to have it be fine. Okay, it's going to be fine. Now, I don't want a new update right now. I don't want to deal with all that nonsense. Okay, we got this. New file. We're just going to call it types.rs. Okay. Now we can start thinking things through. And maybe we'll use... I'll try using this and see how well it works. Alright. But man, it's hard to even think things through. Let me just type, because this is how I think. And if maybe I'll explain some things as we go along. I think that's going to work better for me. Alright, so... let's look back at our notes. Let's get our head back in the game. Spent so much time on that. Yeah, okay, we need to find the world and its types. We have this question answered. Well, let's start with a world type, right? It's going to be a struct. It's going to be public. Right? Pub. There we go. Right, so we start with that. I mean, obviously that's not what we want, but we're getting there. Now, one thing I definitely want is, as much as possible, I want to avoid having lifetimes in my world object. Because if I have lifetimes in my world object, it's going to pollute the entire code base. And I'd rather use more memory than have that, especially for an early version. But the world's one thing we need. Now, what else do we need? We need a player, right? A player's going to have a name. Wait. I got that backwards. Name. I want it to be a string. I don't want it to be a box. Normally what I would use is boxstra. That would work, honestly, in this case. But I'm going to just use a string for now. The reason is I want the string stored outside of the struct. I don't want it to be part of the struct. Because it's... well, actually, if you box it, it's still outside, isn't it? Yeah. Okay. Whatever. We're going to use string because it's easier to access, and this is an MVP. Probably what I want to do at some point is build up some structure around box strings to make it easier to use and just import that in every project or something. But we're not there right now. So, we have our player. What else do we need? Oh, and our world's going to have a list of players. I'm tempted to make it some kind of hash map, but I don't need that right now. A player is going to be a type of actor, though. Do we want to distinguish between players and actors? We probably do. Honestly. Yeah, there are fundamental differences between players and actors that we create ourselves. And this is going to be just vec player. Alright. Looks pretty good. Now, what else do we need? Well, just offhand, we're going to have rooms. A room is an area of the world. It may not necessarily have 4 walls or be a traditional room. It's just going to be an area that you can interact with separately. And a room is going to have an ID, which is going to be a U32, let's say. I kind of want a GUID. What's a GUID type in Rust? Well, we can do that later. We'll start with U32. We can upgrade it. I don't want to put the room name or description here. I don't think. But this is an MVP, and honestly, I don't even know if there would be performance issues, so we're going to do it for now. But I think in the system we want to identify things by ID, not by name. I think that's what we want. Let's call it label, because it's not really a name. And then let's call it description. Now, we may have multiple kinds of descriptions for the same room, and we need some way to modify the description or append things to it based on circumstance, but that's not something we're going to handle now, and it's not something we're going to handle here regardless, although we may need a more complex type to make that more efficient. So we'll think about those things later. What was the other thing we wanted to think about? I wanted to think about representing actors. Right. I don't think there's anything more I need to do other than just remember there's going to be a vector of other actors. Non-player actors. NPCs, I guess, would be another way to say it. They're both actors, right? Okay, we have a label, we have a description. Now, we have some objects that may be in the room, but are they owned by the room? I think they are, actually. I think so. I think the room's going to have an inventory. So we're going to have a trait has inventory. Okay. And this trait's going to have, man, I need some examples here. The inventory is going to be, to keep it simple, I would think the inventory type is going to be, I need to check. I think the best thing to copy from would be iterator or iterable or something. Let's look at the Rust book. No, Rust API? Wait, Rust? Let's check our history here. No. Rust. It's not on crates.io. I think it is docs.rustling, but it's not here. Oh boy. Search the library. Okay, we want to search for iterable. Enumerable. This is where we want to be. Iterator, maybe. It's a struct, though. I want a trait. Iterator. There we go. I want to compare with this. And to be honest with you, maybe what I need is my target type to be an iterator. Okay, but let's start with this. Let's put these together. Think it through, John. Now, there we go. And I want this to be on top. I figured out how to do this recently. Okay. Just a sec. Thinking it through. There we go. Yeah. Okay. All right. Okay. Now you see we have a type here called item. But I want to constrain this type. I don't think that this is really what I want looking at it. I don't want to have that. I think I'm just going to assume the type is going to be an iterator over objects, right? And for now, object is just going to be a type. It's going to have an ID. It's going to have a label or a name. Okay. This looks good. Now then, for my trait, I do want to have some constants, but I don't remember how to define them. I don't even know if it's possible to define constants in traits. I know you can have type level constants like this, but I don't want to do something crazy right now. Yeah. I don't need to be crazy, I just need to work for now. Well, they're all pub, right. Right. Give me a sec, I get some new water right now. It's really dry in here today. Wintertime makes the office super dry. I've been chugging water today, especially since I came in this room. So I guess this room's the driest for some reason. Actually, you know, maybe I can fix that. I think we'll be good for now. So, everything that has an inventory has a maximum number of slots that it can hold, right? Max slots. We'll call that capacity. Yes, that's what we should call that. And this is a function from reference to self. Wait, and self, there we go. Let's use the shorthand. And I think you use this for functions in Rust? I can't remember. In TypeScript, it's different. Okay, and capacity, and we're going to return a U32. We're not going to overthink it right now. Problem here is not having a semicolon? Yes. Okay. Excuse me. We're going to have a put item and self. The item is going to be an object. I don't want to use the word object, though, because I think object is too overloaded. We need a mutable reference, actually. And item, that's right, you have to give the names of the types. Okay. And for this, we want we're going to have an option. It may or may not fit. The obvious reason why it wouldn't fit would be because the capacity has been exceeded. Option. Oh. Well, let's think about this. When we put this reference to an item in, do we want to move it? I think we're overthinking it. I think we'll handle that later. I'm just going to use bool for success. Either succeeded or it didn't. I'm a little bit uncomfortable with this, but when you put an item in, there's no... I mean, what's the valid return value? Let's look at an example. Let's use HashMap as an example. Go from here, away from here. Come on. Wow, things are just not working for me right now. I give up. I'll use the keyboard. HashMap. Let's say you try to put an item in. Okay. Random state I don't care about. Oh, this I probably do care about, actually, this right here. You know, this is looking a lot like a hash map. This has inventory. Looking a lot like a hash map. Okay, capacity, keys, values. We're going to copy this as much as possible, actually. Drain is kind of fun because we could literally have a plot point where something literally goes down the drain, and you trained all the items out of the room. Is it insert? I think it's insert. Yeah, so if we look at insert, option V. Okay, inserts a key value pair into the map. If the map did not have this key present, none is returned. If the map did have this key present, the value is updated and the old value is returned. Okay. The key is not updated, though. So in other words, insert doesn't fail. What about try insert? This can fail, but it has a result type. Tries to insert and returns a mutable reference to the value in the entry. If the map already has this key present, nothing is updated and an error is returned. Okay. So this doesn't really match the behavior. So in other words, for this one, capacity can change. Yeah, the thing about a hash map is it's allowed to grow outside of its capacity. I think that's the real difference here. In our case, it's not. But I really don't know what to do here to force them to handle failures. One thing I could do is, if capacity is exceeded, return the item back to them. I could use move. I could literally use move to store items in there rather than storing references to items. I don't think that's a good idea, though. Maybe it is. Where you literally have to move the item in Rust, and Rust will prevent you from duplicating items then. And if it fails, it returns some item and gives it back to you. Okay, I don't like this API, but we're stuck with it for now. Maybe I just use result. Yeah, I think that's what I'll do. Yeah, I spent way too long thinking about this, and I also lost my window that I had. Oh no, that's the wrong button to hit. I lost 2 windows now. Okay, great. Let's look at result here. Well, that's not what I wanted from life here. Okay, yeah. We're just going to keep it simple for now. Just return a string error if it fails. Let's just keep it real simple. I think this is the right way to do it. We want to force them to handle the error case. Because you can return a bool, but there's no unwrapping that has to happen. Okay, that was way too hard. Get item. Now, get item is not going to fail. Because if the player is not allowed to get an item, let's say there's an item there, but the user is not allowed to get it. It's a real item. It exists as an item. It's not just, anyway, if there's a real item there, and the user's not allowed to get it, we won't call this method, right? This method doesn't have business stuff in it. It doesn't check whether you're allowed to access it. It just does what you tell it, right? It needs to be really simple. Mute self. How do I know which item to get? We are now talking... Okay, we are now talking about a hash map, because I have to store... Well, no. It is basically a hash map, though. Item ID is... Okay, I wish you could do what you can do in TypeScript and do, like, item ID. Does this work? I really doubt it does. Yeah, nothing like that works. Okay. Actually, let's do this, though. Pub type ID equals U32. That way we can update it later. We can change all of our IDs at one time at some point in the future. That sounds good. Okay. And then we want to return a... The only reason I can see for this to fail is if the item doesn't exist. And I'm really considering whether I should be returning a reference to the item or the item itself. If we have a reference to the item, we're implicitly talking about lifetimes. I think I'm going to get rid of that, actually. Okay, yep. Now, if you try to move it in there and it fails, what happens? Does that mean you get the item back? I don't know what Rust does. But also, that's not my problem right now. We'll figure that out when we try to use it. Man, this is hard. It's just getting this... I probably shouldn't have messed with this at this particular stage. I should have done it later. I do want to go to HashMap, though, and see. Try insert. Was that it? No, insert. Just regular insert. I see when we're inserting, we're not inserting a reference to the key, we're inserting the key itself. We want to use the same API because we're going to be calling it directly. So our item ID is going to be passed in directly like that. Okay. And I want to rename this to max capacity because it means something different than capacity on a hash map. Also, what I would like to do is implement deref for this to get at the hash map directly. No, I don't. I actually don't because I never want them to deref it. I want them to use my API directly. Okay. Now we've established that. Okay. Okay, that's just an FYI for later. Great. Okay. What are we missing at this point in terms of types? Let's see. I don't know. I do feel like we're in a good spot though overall. We want the player to be able to modify objects. Oh, here's an idea. Okay. There are items that the user can pick up and put in their inventory. Okay. Excuse me. There are items. Oh, you know what? I realized instead of has inventory, I should do something way easier. Pub struct inventory. Yes, this is way easier and way better. Okay, so we have this is going to be pub max capacity is a U32. It is not an ID though. Comma, yeah. And then we have impl inventory. And we put these in. Backing equals, oh, let's just call it value maybe? I don't know. I mean, we could call it storage, literally. Inventory.storage. What could be more understandable? This is obviously not going to be public. Well, nah. The problem is I don't want to implement inventory in this file, in the types file, but we'll work that out later. Storage is going to be a hash map. Okay. Pub create mod types. It's not going to be create. Okay. Okay. Hash map. I wanted to do something different here, though. Okay, baby's crying. I might have to change things up. Might have to pause the stream. We'll see. I hope we can keep going. Let's see. We'll see if a little bounce in action helps. Okay. So we're key and value. So the key is going to be ID, and the value is going to be an item. Right. Right, we need to import this. Please import. Come on, really? Why does it not give me the option to import like Visual Studio would? Import use? Oh geez, I barely remember. Now where's HashMap stored in life? Let's move this over. There we go. Move it over here. Standard collections. Okay, great. Problem down here. Oh yeah, it needs a body. To do. Okay. Oh, I lost something there. That didn't work out quite right. There we go. Great. And great, now we're getting lots of errors. But, you know, this should be an error. This should be a warning because that needs to be pub. Actually, maybe it shouldn't. It probably should be. Depends on how much we want to trust the rest of the system, I guess. I would say a lot. Now this, I don't want this to be accessible by the outside world. Okay. Okay, so let's go ahead and implement this because I want to get rid of some of these warnings. If self.storage.count len, what was it? Count. We'll find it. It's a len function? Oh, okay. Got it. Okay, guess what? Our max capacity is now going to be a usize because we want to match. If self.storage.len is greater than or equal to self.maxCapacity, then we're going to throw an error. Return, actually, no. Return error. I think that's it, right? Whatever. No, there's okay and failed. What's the problem here? Alright, well apparently I need to look at the result type, because I don't remember. It's error! Okay. Got it. Expected string. Oh, I love it. Let's do this. Well, that causes other issues. If I make it static, that means... Well, we'll just see. We'll just see. Alright. Now, here's the thing. The capacity should never be greater. The length should never be greater than max capacity. If it does, then we've got a programmer error. So I want to make an assert here. Self.storage. Storage.len. Bounce an action less than or equal to self.max capacity. I want to eliminate the case. Let's see, do I have to put anything there? I guess it's an optional message. Okay, I want to eliminate the problem here of it being greater than. So then I just compare for equals, right? I do need to cover the greater than case because I might make an error at some point and cause that to happen. And I don't want, like if the max capacity is exceeded, I don't want it to pretend that the capacity is infinite and just keep putting items in. Yeah. And we don't need to track remaining capacity ourselves. It's already, yeah, we'll just use what's provided to us by the hash map. We want to do as little of the logic ourselves as we can. So if this works, then we do self.storage.insert. We're going to use the item ID. Oopsie daisy. Item.id. Item. And as I recall, oh yeah, we got to return OK. Perfect. Mouse over is not working very well for some reason. I think Rust Analyzer's dead, that's why. Oh, well, why would it... Wait. Okay, let's restart server, I guess. I don't know. Yeah, okay. So it's Rust Analyzer is just not going to work. Okay. What a shame. Okay, just a second. I might have to put this little guy down. Yeah. All right. I'll be back in a sec. All right. There we go. So, that's a good start. I think we might be quitting here today, but let's try and get this get item here. Let's see if we can get this or not. All right. Now let's see. To get an item is really simple. We just need to delete it from the hash map and return it. Right. Excuse me. Let some item equal self.storage.remove. What would that be? I could insert a nonce item, but I don't think that's a very good way to handle it. Okay, let's go back. Remove. Remove a key from the map, returning the value at the key if the key was previously in the map. That's what I want exactly. Dot remove. For some reason it's not... oh, yeah, it's not going to work. It's not going to autocomplete because of Rust Analyzer. Okay, for some reason it can still give me errors, but it's just not able to give me runtime support. That's a shame. Okay. Else. I need an else case. Else. Return. None. Right? Semicolon here. Remove. One argument, 0 oversupply. Okay. Item ID. Uh-oh. Expected that. Okay, right. Actually, to be honest, if it takes an item ID, yeah, if it takes a reference to an ID, let's take a reference to an ID. Let's keep it simple. Now then, if this works, we return some item. Now, the thing is, we should be able to wrap this, like, we should be able to handle this differently. In fact, I just realized something. This is quite obvious. Quite obviously, this get item is just a renaming of remove, right? So this would actually do what I want. If I did self.storage.remove item ID and then return the result. Like that. That does what we want. Because, yeah, we're removing the item as we want, and we're providing that value to the user. If the item doesn't exist, we provide a none value like we're supposed to. So this is just a wrapper. And it also reminds me this name is wrong. We need to change it from get item to take item, probably. Because we're not just getting a reference to an item like we would normally think of. Like, normally get, you don't think of it as being mutating or destructive. We're removing an item, right? Or we're taking something. You could call it stealing. Or, you know what I mean? Or like purloin. I don't know. What should we call it? Retrieve, maybe. Put and take. That works fine. Let's see. With a stack, you would call it push and pop. Yeah, I can't think of a better nomenclature than just put and take, which is kind of what we would have. Put and take is kind of what we would have in the game, right? So it kind of matches the user's language that they're going to use. So it's going to be helpful to. In other words, this is language from our domain. So it's good language to use for a function name because it's coming from our domain. This is something the user's going to do the user's going to use these same words to describe the same action, right? They're going to say put and take. They'll put inside or take out of. They'll use very similar nomenclature to actually cause these functions to get called. So it makes a lot of sense. It fits our domain. This is probably the best language we'll come up with for this really weird interface over a hash map, right? That's all an inventory really is. It's a weird interface over a hash map that has a few business rules. You can't exceed the capacity, and you can't. You can only insert or remove. Those are your only options with items. I suppose you could look at items that are there. You have to have a way to look at items too. I can take that off because we did that. That is our next stage, actually. Yeah. Peruse items. Yeah, I need to be able to get a reference to the items and look at them, but not clone them, right? I don't want to clone them. Excuse me. I don't want to clone them. I want to make sure not to clone them. Okay, so pub function C. Look inside. That's a better. I think that's good. We're not going to mutate it. We don't need any other arguments, and we're going to get. I think we're going to just return values. Let's see values. There we go. This is returning a values object. An iterator visiting all values in arbitrary order. The arbitrary order part bothers me a little bit, but I think there are probably ordered hash maps we can use. And it does kind of keep it fun and interesting for the user. Maybe, if things move around. Well, it makes it harder to read, too, so maybe it's better not to add surprises with no value. Everybody say hello. Say hi. Yeah? Alright. We'll be done soon, don't worry. Okay. Look inside. Right, so the type is going to be values. I don't even know if I can return that type. Whoa, hello. But I think I can say this. An iterator over item, right? I think I can say that. And then it doesn't look like it fails. I mean, if the hash map is empty, it's not going to fail. Self.storage, okay, dot values. And it's a function. Or it's a method, rather. Okay, this is failing. You can return an own trait. I can see why these kind of things are used. Oh, jeez. Okay. Values. Now, where does that... I need to pull it from here. Just going to do that for now. Hopefully that fixes it. Where did the edit last? Oh, great. Everything is working. Okay, we don't need to do anything else. Yeah. So I would like to be able to stop the user from cloning this stuff. I can stop them from copying, but typically when I'm programming, I use clone a lot because I ignore the whole don't copy this value thing. I don't know. We'll see. I guess a lot of this stuff, though, doesn't need to be copied. Like, players are not going to be copied. Rooms are not going to be copied. Well, no. Even if you have copies of a room in your storyline, you can probably implement that with distinct rooms. Like, defined distinctly. So, okay. Now we have our inventory. We decided to get rid of has inventory. And kind of to put the tie the bow on it, so to speak. A room is going to have an inventory of inventory. Is going to be an inventory. And a player is going to have an inventory. There we go. So that's why we don't need the has inventory trait. Because we can do it like that. Now this failed because hash map is a struct, not a module. Okay, let's do it this way then. It's funny, I thought we weren't getting errors because we'd fixed the error, but the reason we weren't getting errors is because we had a more basic error. Cannot find the type values in scope. Consider importing one of these. Yeah, types, hash map values. Use standard collections, hash map. That's what I wanted. Okay, that's what you have to do. Let's do that. Okay, better. 2 generic arguments, 1 was applied. Okay, so fine. It has an ID. I think we're all good. Let's just verify that in the terminal here. I don't remember. I don't think I ran Nick's shell here. Okay. What? Oh, that's right. I moved it. Yeah, I definitely haven't run this. Okay. Nick shell, let's just see that this works. Cargo build. Lifetime is elided here. Okay. Hiding a lifetime that's elided elsewhere is confusing. I agree. But the same lifetime is referred to in inconsistent ways, making the signature confusing. So, if I do this... No, I can't do that. That's better, though. I do agree with that change. Alright. Okay. Let's look at our get ignore. Looks fine to me. Where's our shell.nix? Oh yeah, I intentionally hide those. Ship it! Alright. So, if I could, if I had 2 arms, at the moment I would go ahead and try to diagram some of this, but what we got a world full of players. You know what? It's going to be full of rooms. I don't know if the Vec's the right struct, though, or the right structure for that. It probably needs to be a graph of rooms. Yeah, we need to find a graph of rooms somehow. I could use a custom type, but it'd be nice if there's something built in that's usable. Yeah, I'll have to research that and find something. We have players, we have rooms. The players have an inventory and a name. You know what? Players are also going to have an ID. That's just normal stuff. They're going to have an ID. Rooms have an ID, a label, a description. They have an inventory as well as a player. So the idea is you can take something out of a room inventory and put it in a player inventory. In fact, we might do something like, we might make a transfer interface where it's like, hey, transfer from this inventory to this other inventory. That's kind of fun. Instead of take item, maybe? Yeah, that seems good. Like maybe we still have these functions, but they're not public or something. Yeah, I think what we should do is make these private and then add a transfer inventory item function. Let's do that. Oh man. Maybe we can do that. Transfer. We're going to mutate both of them. And then we're going to have other. I really would like to name this something different. Can I get away with that? From. You know what? Let's rename the function. Transfer to. There. Okay. And then we're going to have, uh-oh. Well, we might be done for the day. All right, somebody's getting grumpy. So I hope you guys have enjoyed this, and I'll catch you all later. Take care now.